and welcome back to my channel. In this video, we are going to look at theorems and postulates to know for perpendicular and parallel lines. The first postulate is the parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. For an example, there is exactly one line through point P that is parallel to line L. Postulate 3.2 Perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. For example, there is exactly one line through point P that is perpendicular to line L. The first theorem of this video is corresponding angles. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Examples of corresponding angles include angle 2 and angle 6, angle 3 and angle 7, angle 1 and angle 5, and angle 4 and angle 8. These angles are congruent using this theorem. Theorem 3.2 Alternate interior angles. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. For example, angle 3 and angle 6 are congruent, and angle 4 and angle 5 are congruent using this theorem. The next theorem is the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. For example, angle 1 and angle 8 are congruent, and angle 2 and angle 7 are congruent based on this theorem. Theorem 3.4 Consecutive interior angles. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. For example, angle 3 and angle 5 are supplementary, and angle 4 and angle 6 are supplementary, meaning they add up to 180 degrees. Theorem 3.5 Corresponding angles converse. Remember, converse means you flip the hypothesis and the conclusion in an if-then statement. Now, if we are given the angles, we can prove if lines are parallel. If two lines are cut by a transversal so the corresponding angles are congruent, then the lines are parallel. For example, if angle 1 and angle 5 are congruent, then line M and N must be parallel. Theorem 3.6 Alternate interior angles converse. If two lines are cut by a transversal so the alternate interior angles are congruent, then the lines are parallel. For example, if angles 3 and 6 are congruent, then M and N are parallel lines. Theorem 3.7 Alternate exterior angles converse. If two lines are cut by a transversal so the alternate exterior angles are congruent, then the lines are parallel. For example, if angle 1 and angle 8 are congruent, then lines M and N must be parallel. Finally, Theorem 3.8 Consecutive interior angles converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, which means they add up to 180, then the lines are parallel. For example, if the sum of the angle measurements of angle 4 and angle 6 is 180 degrees, then line M and N are parallel lines. Here are some other theorems that you will need to know. Theorem 3.9 Transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Therefore, if line L and line M are both parallel to line N, then line L and line N must be parallel to each other. The next theorem is the linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. For example, if angle 1 and angle 2 in this image are congruent, then line N must be perpendicular to line M. The next theorem is the perpendicular transversal theorem. So, in this plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well. For example, If line T is a transversal that is perpendicular to line N, then line N and line M are parallel lines, then line T is also perpendicular to line M. Theorem 3.12, lines perpendicular to a transversal. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. For example, if line M is perpendicular to line P and line N is also perpendicular to line P, then M and N must both be parallel to each other. Theorem 3.13, slopes of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. For example, a line A and line B are non-vertical lines. If their slopes are the same, then they are parallel lines. Theorem 3.14, slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. Horizontal lines are perpendicular to vertical lines. For example, line A and line B are perpendicular if the product of their slope is -1.